Hi everyone, we are now with our next topic, which is sequence and series. This topic shouldn't be new to you because you were able to discuss this when you were in grade 10. Some of you might have took this when during the first quarter. Some might have took this during the second quarter, especially those who graduated or who moved up coming from the junior high school of Holy Angel University. Now, let's have the following figures first before we go to the lesson itself. So what's next? So at the beginning, you only have one dot. And then at 1 minute, you already have 5 dots. At 2 minutes, you have 9 dots. So with that, you can actually come up with the following. Assuming the sequence continues in the same way, how many dots are there at 3 minutes? Okay, there will now be, yes, there will be 13 dots. And then 4 minutes, correct, that is 17 dots. And 5 minutes, you have 21 dots. So how are we able to come up with these answers? You actually came up with patterns. So at the beginning, you have 1, and then at 1 minute, it became 5, and then at 2 minutes, it became 9. So writing it down, you actually have 1, and then 5, and then 9. So if we're going to continue the pattern, we're going to have 13, 17, 21. So the pattern goes on. Actually, the pattern that we're able to come up with is addition of 4. So you only have to add 4 from the previous term for you to get the next term. I am talking about the word terms. We'll have the discussion of that, okay, later. How about this one? At the beginning, you have 3. At 1 minute, you have 6. At 2 minutes, you have 12. At 3 minutes, you have 24. And at 4 minutes, you have 48. Were you able to come up with the pattern given this figure? So writing it down, you have 3, and then 6, and then 12, and then 24, and then 48. So if I am going to ask you to continue with the pattern, you can actually come up with the next one as, yes, that's 96, and then so on. So what pattern have we generated from this given figure? So as you can observe, for you to get the next term, you have to multiply 2, right? Multiply 2 for you to get the next term. And that's the pattern that we see for this one. This one, we have 1, and then 4, and then 9, and then 16. What numbers are these? These are actually square numbers. So it's like getting, forming a square, okay? But we're going to add up the row and the column. So if we're going to get the next number, it will be 25, and then 36, and then 49, and so on. And this one, triangular numbers. So you have 1, 3, you have 6, you have, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay. And then what will be the next one? It's actually 15. Okay. And then you're going to have 21. Yes. If you're going to look at the pattern given, you don't actually multiply or add the same number. You are adding up an increasing number. So you add 2, and then you add 3, you add 4, add 5, and so on for you to get the next term. But again, these are still sequences because they have patterns on it. So all these are called sequences and series. Okay, so we're going to deal with this topic, but we're going to focus more on arithmetic and geometric. So let us have this one. Think, write, and share. I want you to reflect on this. You actually already have an idea on this. So after reading this, you may actually pause, okay, this video for you to come up with your own idea first before I go on with the discussion. So what do you know about sequences and series? Write it down. Differentiate arithmetic from geometric. Think back to the lesson over and write down everything you remember. Try to recall the formulas too. So again, I want you to pause this video first and then try to answer this one, and then let's have the discussion after. So what's the difference? So on the left group of numbers, you have 3, 8, 13, 18. On the right side, you have 3, 8, 13, and 18. But this time, they are not just being enumerated. They are being added. So on the left side, you have comma, okay, to separate each number. On the right side, you have the plus sign to separate each number. The left side is actually called a sequence, okay, wherein the terms, okay, of that sequence is actually being enumerated. The right side is now called series. It is called series because we are now trying to get the sum of the terms of the sequence. A sequence is a list of numbers written in a specific order. Again, you have to be careful with this because we cannot just write the numbers or enumerate the numbers without looking at the pattern, without looking at the order, because that order is very important. In series, it is now the sum of the terms in a sequence. So again, if there's a comma separating the terms, that is just a sequence. If there's a plus sign separating the terms, that is now called series. Let us now focus on the arithmetic sequence first. So what will I do is I am going to give all the definitions and formulas since this is not new to you, okay? So I'll be giving all the formulas and definition needed, and then later I am going to give examples, okay? We actually have 10 examples. So if you want to work on it on your own, you may actually pause the video and answer it before you watch the solution. So arithmetic sequence, a sequence in which each term after the first is obtained by adding a constant. That constant number is called the common difference, okay? This common difference is actually being applied for you to get the preceding terms. Now, 3, 5, 7, 9, 11 is our first example. If you're going to use the formula A sub n is equal to A sub 1 plus quantity n minus 1d, recalling it, that is actually the formula in getting the nth term of an arithmetic sequence. Now, let us apply this formula with the given example, 3, 5, 7, 9, 11. Okay? When we say A sub n, this is actually the nth term, okay, of the given arithmetic sequence. Now, A sub 1 is the first term, and this is the number of terms. So I just want to reiterate this one. Whatever n you have here should also be the same n on this one, okay? These should not be different. They should be the same since they represent the same number. And D is called the common difference. So, for example, I want to get the 10th term, okay? The 10th term of this example, okay? You're now going to have A sub 10. A sub 1 is the first term of the sequence. So, A sub 1 is actually the first term, which is 3. The number of terms needed in this problem, since you're looking for the 10th term, and now will also be equal to 10. As mentioned a while ago, they should be the same. And the common difference. Now, how will we know what is the common difference of a given arithmetic sequence? You only have to do subtraction. So what should I subtract? You only have to subtract the second term by the first term. You can actually do that for any terms, any succeeding terms. So you want to subtract A sub 4 to A sub 3, that's fine. If you want to subtract a sub 6 to a sub 5, again, that's okay. Of course, you have to know first, okay, which will be easier for you. There are times that there are negative numbers and positive numbers involved in a sequence. So I think it's easier for you to solve those that are positive rather than the negative, okay? As long as they are the succeeding numbers. So if you have this example, I think it's easier for us to subtract 5 and 3. So you're going to have 5 minus 3 equals 2. Therefore, the common difference is 2. Now, series. We already had the idea or the recall for arithmetic sequence. Let us now have the recall for arithmetic series. So what difference do we have? It's just the sum, okay? We're dealing with the same terms. We're dealing with the same pattern, but this time we are adding up the first few terms of that given sequence. So the formula that we're going to use, okay, is S sub n is equal to n over 2 quantity to a sub 1 plus n minus 1d. Actually, at most cases, I usually give them or give my students this formula, the second one, because this might look easier, yeah, because you have several numbers involved on the first one. But at the same time, you'll be able to see the difference of having the pattern from the sum itself or from the sequence itself. You just have to take note that on the second formula, you have a sub n here. It means that you have to solve for the nth term first or the last term first before you can have the sum of the first n terms. Unlike on this one, the first formula, whether you know the last term or not, you're able to solve it. But actually, this is just the derivation of the formula for A sub n. So parang sinubstitute na lang si A sub n dito. So kung ito si A sub n dyan, nandito yung A sub 1 dun sa A sub n, tapos may n minus 1d pa rin kayo. So it's just the same. So let us now talk about the parts. Again, when we say A sub 1, that is just the first term. A sub n, that is the nth term or the last term involved. Again, whatever n you have here, they should be the same for the number of terms. S sub n, since it is now denoted by S, we're now dealing with the sum or the series, okay, of the sequence. And D, of course, is still the common difference. Okay, we're done with arithmetic. So let's now go to the next part, which is geometric. So geometric sequence, as you can see on the video shown or in the GIF shown on the right side of this presentation, you see these are actually bacteria growing. And we know that bacteria doesn't grow just one in after a few times. They actually multiply. Okay, they multiply. The term is multiply. Because when we say geometric sequence, we are actually dealing with a sequence wherein you have to multiply a certain number to get the next term. So let me read. A sequence in which each term after the first is obtained by multiplying the preceding term by a constant number. And that constant is called the common ratio. So again, kapag arithmetic ang pinag-uusapan, meron tayo common difference. Pero kapag geometric, ang meron tayo ay common ratio na. Okay, and that will now be denoted by R. So this is the example. 1, 2, 4, 8, 16. So if you're going to look at the pattern, and for you to generate the next term, you don't add anymore. You multiply a certain number. So that becomes geometric. Now, what formula do we use for geometric? A sub n is equal to A sub 1 multiplied by R raised to n minus 1. So wala ka na makikitang D dyan, but instead you're going to have R. And kanina, we usually have multiplication and addition. This time, we have multiplication and exponent. So nag-level up din ng konti yung ating operations. Next, let us now have the interpretation of each part of this formula. So we are aware already that A sub n is the nth term, A sub 1 is the first term, okay? N is the number of terms and R is the common ratio. So let us identify each, okay, on this given sequence. So you have 1, 2, 4, 8, 16. So if we're looking for the 10th term again, or let us say 8th term, para maiba naman. So your a sub n, okay, will now be the 8th term. So you're now going to use a sub 8. Okay, a sub 1 is the first term. So on our given, the first term is 1. N should be the same as a sub n. I mean, n there should be the same. So you have number of terms involved, 8, and common ratio. Kanina, common difference, we subtract a sub 2 by a sub 1. Common ratio naman, from the term itself, ratio, we are now dividing. So we will divide a sub 2 by a sub 1 or any succeeding terms. As mentioned a while ago, any succeeding terms. So you can divide a sub 4 to a sub 3. You just have to remember that it should be you should be dividing from right to left, not from left to right. So it should be the higher. It's not always higher. Or if you have a sub 10 and a sub 9, that should be a sub 10 over a sub 9. It should not be a sub 9 over a sub 10, because you're going to have a different answer on that. Okay? So applying this one, a sub 2 over a sub 1, we know that a sub 2, second term is 2. A sub 1 is 1. So 2 divided by 1, simplifying it, we now have a common ratio of 2. Okay? Let us now have series naman. So again, it's just the same. We have the same terms, but this time we're going to add up the terms. So this is the formula used for geometric series. We have S sub n is equal to a sub 1 minus r times a sub 1 or a sub n. That is the last term of the sequence over 1 minus r. That is if your common ratio is not 1. Okay? We cannot have 1 as your common ratio for this problem because you're going to have 1 minus 1 equals 0. And we know that any number divided by 0 will be undefined. Okay? This is another formula used. You have a sub 1 minus a sub 1 multiplied by r raised to n, okay, over 1 minus r, wherein r again should not be equal to 1. Okay. So you have a sub 1, the first term, a sub n, the nth term, and the number of terms, s sub n, the sum of the first n terms, okay, first n terms, and r is the common ratio. Actually, you are free to use any of the information or any of the formula given. You just have to take note that the first formula requires you to have the value for the last term or a sub n. So if you don't have a sub n, then you can use the second formula. But if you want to use the first formula, which you think is easier, okay, because it doesn't involve much exponent, pero kasi si a sub n may exponent din naman eh. So derivation lang naman po ito. You can still use any wherever you are comfortable. So let us now have the examples. This is the first one. So I am going to solve all of this, but again, if you are ready to solve them on your own, you can always pause this video and then solve it, okay? So number 1, find the 10th term in the sequence 19, 24, 29, 34. So we have to get the 10th term, and you are given the sequence. But the question here is, what kind of sequence do we have? Is it arithmetic or geometric? Okay? So you have to check first, anong pattern ba meron? Nag-a-add ba tayo o nagmumultiply? So kung nag-a-add tayo, then it means we have arithmetic sequence. Pero kung nagmumultiply tayo, it means you are in geometric. So you try first subtracting, syempre. Let's see. You have 19 to 24, 24 to 29, 29 to 34. So from here, we know that there is a difference of 5. So kung difference lang ang meron tayo at hindi ratio, then it means you have an arithmetic sequence. Okay? Since we have an arithmetic sequence, we can now actually use the formula a sub n is equal to a sub 1 plus quantity n minus 1 d. Okay? Now, before we proceed with the answer, let us identify first all the needed information. So, we'll start with a sub 1, the first term. And on this example, our first term is 19. And then n, we are looking for the 10th term, therefore n is 10. Okay? And the common difference. Since we know that we're adding up 5 to get the next term, or if you want to apply the formula mentioned a while ago, we subtract 24 minus 19, that is actually 5. So the common difference is 5. Look, whether I subtract the last term, 34 minus 29, you will still get 5 because you should have the same difference. That's why it's called common difference. Okay? Let us now proceed answering. So we're looking for a sub 10. We substitute a sub 1. And then substitute n with 10. Then subtract 1. Then multiply d, which is 5. Okay? So, proceeding. A sub 10 is equal to 19 plus, we subtract first before we multiply. So, 9 times 5. So, we multiply before adding. So, 19 plus 9 times 5 is actually 45. And then we add finally. So, 19 plus 45, that is 64. And our 10th term is 64, and that's the answer. Second, find the 8th term in the sequence 4, 16, 64. 4, 16, 64. So, if you're going to look at it, you are not adding up already. You are actually multiplying a certain number to get the next term. Okay? So, hindi na common difference ang meron tayo. Meron na tayong common ratio. Okay? And dahil common ratio ang pinag-uusapan natin, it means we are under geometric sequence. And the formula for geometric, you have a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So let us identify our unknown first, or sorry, our given first. So a sub 1, the first term, 4. And then we're looking for the 8th term, therefore n is equal to 8. And our common ratio r, so what number are we multiplying to generate the next term? Or we simply divide the second term by the first term, 16 divided by 4. So that means your common ratio is 4. So let us now solve using the formula. So we substitute a sub 8 is equal to a sub 1, which is 4. R, common ratio, 4. I am going to put parentheses here so that we know that we are dealing with multiplication. Okay? Then raised to n minus 1. So n is 8 minus 1. So a sub 8 is equal to 4. We simplify the exponent first. So that is 7. A sub 8 is equal to 4. So let us now have 4 raised to 7. You can actually use your calculators. So 4 raised to 7 is equal to 16,384. So we multiply 16,384 to 4. So that is actually 65,536. For the third example, we have evaluate the sum of the first 14 terms of the sequence 13, 15, 17, 19, 21, 23 to 39. So in this example, we're supposed to get the sum of the first 14 terms. But as you can see, in this problem, you were able, or you are given, okay, the first and the 14th term. So it means you can actually use the second formula, S sub n is equal to n over 2 multiplied by a sub 1 plus a sub n. Okay? But if you want to use the other formula, like I don't want to use 39 as the last term, so I want to use the other formula. Will I be getting the same answer? We'll see later. Okay, I'll be showing both. So formula, S sub n is equal to n over 2 multiplied by a sub 1 plus a sub n. Let us now identify our given first. So we know that a sub 1, the first term is 13. N, we're looking for the first 14 term, so n is equal to 14. And the common difference, though you're not going to use the common difference here, we're going. So this is all, again. Let us have the third example. Evaluate the sum of the first 14 terms in the sequence 13, 15, 17, 19, 21, 23, up to 39. So in this example, you are given the first and the last term. Okay? So with that, you will actually be able to answer it easier. So we'll be using the easier solution. But of course, we have to know first, are we dealing with arithmetic sequence or geometric sequence? So check your given first. Looking at the pattern, we are only adding up 2 to get the next term. Therefore, the common difference is 2. Okay? Again, since we have common difference, then we are dealing with arithmetic sequence. So let us now have the sum of the first 14 terms. We will now be using the formula S sub n is equal to n over 2 multiplied by a sub 1 plus a sub n. Okay? What are the given? We have a sub 1, 13, and a sub n, or a sub, we write the last term already. So we have a sub 14, which is 39. So we only have to substitute S sub 14. We're looking for the sum of the first 14 terms. We substitute n, 14 over 2, then multiply a sub 1, 13, a sub n, 39. You may simplify 14 and 2 already. So that is 7. Then 13 and 39 we add. So that is 52. So we just have to multiply 14 and, multiply 7 and 52. So you have 364. So this is now the final answer. So if we're going to enumerate all the numbers from 13 to 39 following the same pattern, the total sum is 364. Okay. Number 4, evaluate the sum of the first 16 terms in the sequence 20, 27, 34, 41, and so on. So in this one, we have here a different way of solving it. So as you can see, you are not given the last term. Therefore, we should be using the next formula, which is S sub n is equal to n over 2 quantity 2a sub 1 plus quantity n minus 1 d. So let us identify first our given. A sub 1 is equal to 20. And we're looking for the first 16 terms, therefore n is 16. And then we need to have our common difference, d. So you have 20, 27, 34, 41. So this is 7. 27 minus 27. Okay? But again, of course, you have to identify first whether you have an arithmetic sequence or a geometric sequence, okay? Before you proceed to the solving part, because you might be using the wrong formula, okay? So let us now substitute with the formula. We have S sub n, or S sub 16, since we're looking for the first 16 terms. Then 16 divided by 2, multiplied by 2, times A sub 1 is 20, plus n is 16 minus 1, and the common difference is 7. Simplify. You might be asking, what if, ma'am, we don't have 16 here, like 19 or any odd number? So it's possible for you to have an answer which is decimal or fraction. So you have 16 divided by 2, 8. Multiplied by 2 times 20, you have 40. Plus 16 minus 1 is 15 times 7. You can actually multiply this right away if you want to, wherever you are comfortable. So you have 40, and then we multiply 15 and 7, so that is 105. So we add 40 plus 105, that is 145. So S sub 16, 8 times 145 is equal to 1,160. And the sum of the first 16 terms is equal to 1,160, and that is the final answer. Number 5, evaluate the sum of the first 9 terms in the sequence 2, 6, 18, 54, 162, 486, 13,122. So this is now an example of a geometric sequence. As you can see, you have to multiply a certain number for you to get the next term. But in this example, there is actually the first and the last term is actually given. So we will now be using the formula wherein you are given the first and the last term. Okay, since the last term is already indicated, which is 13,122, and the first term is 2. So we have the formula S sub n is equal to a sub 1 minus r times a sub n over 1 minus r. Okay, so we just have to substitute. We know that a sub 1 is equal to 2, and a sub n is equal to 13,122, while r is equal to, again, if you were not able to identify it yet, you may divide second term to the first term, so r is equal to 3. Okay, let us now substitute. We're looking for the first 9 terms. So you have s sub 9 is equal to a sub 1, which is 2, minus r multiplied, we can substitute that right away. So you have 3 times a sub n, which is 13,122, all over 1 minus r, which is 3. So let's multiply first 3 and 13,122. That is actually 39,366. Okay. Then we may subtract 1 and 3 right away, so that is negative 2. So we simplify, we subtract this, so you're going to get negative 39,364. We divide it with negative 2, and you are dividing both negative. Therefore, our answer will be positive. So you're going to have 39,364 divided by 2 is equal to 19,682. And this is the sum of the first 9 terms of our geometric sequence. And example 6, we have evaluate the sum of the first 6 terms in the sequence 1, 6, 36, and so on. So again, this is an example of geometric sequence. So as you can see, we are multiplying 6 to get or to obtain the next term. But we are not given the last term of it. So it means we have to solve using the next formula, the other formula. S sub n is equal to a sub 1 minus a sub 1 multiplied by r raised to n. Since we don't have our last term, over 1 minus r. So we know that our first term is 1 and our common ratio is 6, since when you divide 6 by 1, 6. So we're looking for the first 6 terms. So you have s sub 6 is equal to e sub 1, which is 1, minus 1 times r, 6 raised to n, 6, over 1 minus r, 6. Okay, so we have to get the exponent first, simplify the exponent. We may actually remove 1 here because whatever value we'll get here, it's just the same if you're going to multiply it with 1. So we just have to simplify 6 raised to 6 now. So 6 raised to 6 is actually equal to, okay, 46,656 over 1 minus 6. Let us now have subtraction for both numerator and denominator. So you'll have negative 46,655 over 1 minus 6, negative 5. So S sub 6 is equal to 46,655 divided by 5 is equal to 9,331. Okay. And this is the final answer for the sum of the first 6 terms of the given geometric sequence. Now, for the next set, we're now going to have application problems or word problems involving sequences. Okay, so there will be more problems, or sorry, more readings to analyze. Okay, unlike the other one, you only have to identify whether it is geometric or arithmetic, and then you apply the formula right away. Okay, this one you have to identify the whole pattern first. So let's see. So we have here, a theater has 26 seats in row 1, 29 seats in row 2, and 32 seats in row 3, and so on. If this pattern continues, how many seats in row 42? So for us to easier understand it, it's actually imperative, or actually it's easier for us to have this by writing down the sequence itself. So we know that on the first row you have 26. On the second row, you have 29. On the third row, you have 32. Okay, and then it goes on. What we're looking for is the 42nd row. So how many seats do we have on the 42nd row? So by looking at our given, we are actually adding up a number of seats for you to go to the next row, right? So with that, we're adding up a number. So it means we are just dealing with arithmetic. But the question is, should we have arithmetic sequence or arithmetic series? Since it says that we only have to identify the number of seats in row 42, and it didn't tell us to get all the number of seats from row 1 to row 42, it means you only have to get A sub 42, not S sub 42. I repeat, you are only asked to get the number of seats on the 42nd row, not the total seats from the 1st to 42nd. Therefore, we're looking for A sub 42. So, let us now apply the formula A sub n is equal to A sub 1 plus quantity n minus 1d. We substitute A sub 42. We know that the first term is 26. And then we're looking for the 42nd row, so 42 for n, minus 1, and then the common difference. So check. What number are we? What number do we add up to next to get the next term? So that is actually 3. So you have A sub 42 equals 26 plus 42 minus 1 is actually 41. multiplied by 3. So we have 26 plus, we multiply this, it's actually 123. Then a sub 42 is equal to 26 plus 123, so you have 149. Therefore, on the 42nd row, we already have 149 seats. And that's it. 8. Okay, this is quite long, but it will not be that many actually. It's easy for us to solve this one. So one day you joined a trending challenge in Facebook, which requires you to mention or tag 3 of your friends. At 1 p.m., you mention 3 of your closest friends. Then at 2 p.m., each of your mentioned friends tag 3 of their closest friends without repeating the names you've already mentioned. Then at 3 p.m., the same scenario happened. If this pattern kept happening, how many unique people have been mentioned until 9 p.m.? Okay, so let's analyze it first. So you started with one person from you, 1. Okay, and then you tag 3 of your friends on at 1 p.m. Okay, at 1 p.m. So we see that this is at 12 p.m. Or you can actually start with 3 right away for us to have lesser numbers involved. So you have 3 persons involved, and then these 3 persons were able to tag 3 from each. So how many is that? So if you're going to put some branches, that is actually 3 times 3, so you have 9. And then for the next one, it happened again. So you just have to multiply 3 by 9 again. So that is 27. Take note ha, wala pong nauulit na friend. So ibig sabihin na dadagdagan sila. Okay? So the pattern goes on. But actually, it is already mentioned that the pattern that we apply is we multiply 3 to the next. So this is at 1 p.m. What we have to look after is the number of tagged friends at 9 p.m. So with that, we will now be applying the formula S sub n is equal to n over, let me correct that. So S sub n is equal to a sub 1 minus a sub 1 times r raised to n over 1 minus r. Okay. So we are looking for the number of people tagged until 9 p.m. So that means it includes the first hour until the next hour or the last hour. So we are looking for S sub 9 equals a sub 1, 3, since we already tagged 3 friends at first. 3 times r, so r is 3 raised to n, 9, over 1 minus 3. So we'll now simplify. Unlike kanina, meron tayo 1. So tinanggal natin si 1 kagad. But this time, hindi natin siya pwedeng tanggalin. So we'll have the exponent first, 3 minus 3, 3 raised to 9 first. So we are going to have the exponent first, and that is 19,683 over 1 minus 3. So you have negative 2. So let me continue on this side. So S sub 9 is equal to 3 minus, the answer will now be multiplied by 3. So you have 59,049 over negative 2. So we just have to subtract. So 3 minus 59,000 for 49, that is 59,046 negative, and then divided by negative 2. So since again they are both negative, our result will be positive. So the final answer now is S sub 9 is equal to 29,500 23. So these are the total number of tag people. So imagine if you're going to do that, and if everyone will be doing it for with just 9 hours, you'll be able to reach 29,523 persons. For our ninth example, we have Kyla starts with 25 pesos in her allowance account. Each week that she does her chores, she receives 10 pesos from her parents. Assuming she doesn't spend any money, how much money will Kyla have saved after 15 weeks? Okay, so with this example, Kyla started with 25 pesos. And then each week, she receives 10 pesos from her parents. So second week, she has 35 and then 45 and so on. So the question here is, how much money will she be able to save after 15 weeks? So we are looking for the 15th term of our sequence. Therefore, we will now be using A sub n is equal to A sub 1 plus quantity n minus 1d. So you have A sub 15 is equal to, first term is 25 plus n is 15 again, minus 1. And then d, common difference, since she's adding up 10 pesos from her savings, so we're going to use 10. A sub 15 is equal to 25, parenthesis first, so you have 14 times 10. Then we'll have 25 plus 140. Therefore, A sub 15 is 165. Therefore, Kyla was able to save 165 pesos after 15 weeks. And that is the answer. And for our last example, Dr. Franklin begins an experiment with the culture of bacteria in a container. On his observation, the culture of bacteria doubles every 2 hours. If there are 100 bacteria at the beginning, how many bacteria will there be in the 10th hour? So we started with 100 and then it doubles. So naging 200 siya, tas naging 400 siya, and so on. But the question here is, it doubles every 2 hours. And we're looking for the 10th hour. So we cannot say that n is equal to 10. Kasi every 2 hours lang siya nangyayari. Therefore, we're going to divide 10 by 2. Therefore, we'll have n as 5. Okay? We'll not be using 10. Kasi nga po, nagdodoble siya every 2 hours. So, every 2 hours, 2 hours, 2 hours. So, limang beses lang siya mag-occur. Okay? So, let us now solve. Since nagdodoble, ibig sabihin, nagmumultiply tayo sa 2. So, we are with geometric sequence. So, you'll have A sub 5 is equal to A sub 1 multiplied by R raised to n minus 1. So, A sub 5 is equal to the first term 100. R is 2 since it doubles. Okay? It raised to 5 minus 1. We simplify the exponent first. So, you have 4. Then 2 raised to 4, that is 2 times 2 times 2 times 2. So you have 16. And A sub 5 is equal to 1,600. Therefore, there will now be 1,600 bacteria in the 10th hour. So that's it. These are all the examples that we have for sequence and series. We're going to have formulation, or what we call summation notation, on our next lesson. That video will be posted later. So for our summary, here is our formula for both arithmetic and geometric sequence and series. But take note, we have 2 sets of formula for series. That one wherein you are given the last term, and the other wherein A sub n is not given. So for your activity, so here is the LAS that you should accomplish. So there will be two parts, one for geometric and one for arithmetic. So since we're done with arithmetic, so find the pattern. There are given learning targets to define arithmetic and geometric sequence. Find the nth term of a sequence. List down terms which are part of the sequence, and solve real-life problems involving arithmetic and geometric sequence. So first part, page 249 and 252, items 1 and 2, 5, 6, and 9, and 34. For geometric sequence, you have page 261, items 1 and 2, and 5 and 9. So these are all the items that you have to finish. This will be posted in Orange apps, and it will be indicated when to submit. Thanks, everyone. I'll see you again.